Welcome to the first part, the descriptive statistic part of the chapter 28 multiple regression SDM4 and R. We'll be coming back to this chapter later on in the course once we've actually done inference. But because multiple regression is such a powerful and important technique to allow us to disambiguate relationships with three or more variables, we're doing this earlier in the book as a way of really trying to build your understanding of modeling. The section here you want to really be paying attention to is this definition in 28.1 of what we actually mean by multiple regression. And then thinking about how that might show up, and there's an example here where we're modeling body fat as a function of the waist circumference and height of these subjects. And we're thinking really of kind of coming up with a model that has not one but two predictors. So it allows us to simultaneously control for two different things. Working through each of these examples is going to be very helpful. Everything is put together in the SDM4 and R routines. Really the difficulty in this comes up in how we put the models together, mostly the focus for the next course in statistics, but interpreting multiple regression coefficients, because that is a little trickier than it was just for a single predictor. And this example kind of takes us through that and works through, which is going to be very helpful for us. The assumptions and conditions are a little bit more complicated. They're still the line assumptions we used for linear regression, but we just need to be thinking those in other dimensions because now we have different variables. We're really dealing in the number of predictors and the outcome, so whatever that p predictor is plus 1 is p plus 1 dimensional space. So we still need to look at equal variance, still need to look at normality. Linearity is a little bit trickier because there's multiple ways to look at linearity. The step-by-step example is accessible. We have this model put together. You'll notice there's some stuff here on the right-hand side with the standard errors, t-values, and p-values. Don't worry about those right now. That's the inferential part we'll come back to later. This section 28.4 on inference really talks a little bit more about the how to be careful interpreting these coefficients. And that is an important topic and idea to be thinking about right now. We'll come back more for the inferential things. There's another nice example here with infant mortality, which is worthwhile going through. And then there's a think, show, tell. Finally, this last aspect of comparing multiple regression models, we'll be using multiple regression in our projects, the group projects at the end of the semester. We will have you fit a couple models with that, but I'm going to be your guide in how to put that together. There are some techniques and approaches. The most challenging part of this really is interpreting the coefficients of a model. And so we have to be very careful in that. The what can go wrong here is very, very helpful. And then other aspects of thinking about what else can go wrong. Lots of important learning outcomes here, really thinking about the idea of having more than one predictor in our model and how we can be thinking about that in multiple dimensions. Code, really not much new here. We're using the LM function, except we now have two predictors for that. There's a nice example on the SDM4 in R that talks about how we can use the make fun option to go ahead and query and interrogate aspects, generating predicted values from the models. A little bit more on looking at the coefficients, these partial regression plots. There's a nice way of displaying things in terms of what we call a pairs plot. And these are the data from the infant mortality. And then similarly, a nicer one for the height, waist, and percent body fat that get put together. And then finally, this part of the SDM4 and R, the online supplements that describe how to do things in R, shows about how to go ahead and compare models. Enjoy!